Nintendo Switch. Let me show you what's going on. Looks like the port has seen some better days. I was going to do a power test just to see, but it looks like we got some at least one misplaced pin, and I don't want to risk shortening anything together and doing any more damage, so we're definitely going to be going after this port first, and then we'll see if there's anything else we have to worry about after that. Alright, time to disassemble, and I'll come back when we're ready to get after that port. Okay, we are set up in the board holder and ready to pull this port. Alright, before we get started, and while I set up my equipment, let's throw up our expected temperatures for this job. Alright, switch it back behind the microscope. And we will do what we always do. We will flood all visible areas with low melt. Oh yeah, that's very nicely broken. Alright, so unfortunately that came off really poorly, and we got lots of pull pads. When they're jammed up like that, that can happen. It was not because of our pull. You've seen me do this pull a million times. So as you can see, there's even broken anchor joints and everything else, so it was jammed pretty good. The damage was already done. Alright, so I need to clear these bridges so we can do further testing and make sure that's the only problem we have. Alright, we'll start around the M92 T36 per usual, but we'll start with the 5.3 USB capacitor. Alright, so the one line we're worried about on that capacitor is the one going to the M92 T36, and it is not shorted, so that's good. And again, we're following all the lines to the chips. That's the side we generally don't want shorted. The only exception to that is if there's two lines going to the chip. And if there's two lines going to the chip, one of those will be ground on a capacitor, and that one right there would be ground. Okay, everything looks alright so far. Check our MOSFETs. MOSFETs seem okay. Check our little filter. The filter seems okay. Check our invincible fuse. Invincible fuse seems okay. Now we're going to check all of our pads. I'm mainly just going to check these in this area, the ones I know that shouldn't be short. I'm not going to worry about testing the ground. Up here is the ground, so actually we just use it for testing. Make sure there is no pathway to ground on any of these, and there is, so that tells me that we have a bad M92 as well. Let's make sure we have no shorted here. Yeah, so we have a bad M92 T36 as well. So we're probably just going to remove that and make sure that short goes away. Alright, now those should be shorted. Let's check around our BQ24193. Make sure we don't have a short there. Okay, coil is not shorted. Alright, back on ground. Okay, everything around the BQ24193 seems fine. Same rules on the BQ24193. If it has two, and it does have several that have two lines going to the chip, one of those will be ground, so don't be alarmed. Pick our Pi 3 USB for any problems. Okay, seems alright there. Let's just double check, make sure we have no shorts on all these. Or they're not bricked together anyway. And everything's fine. Very good. So let's pull the M92T36 and make sure that short gets relieved. I want to make sure shorts get relieved, otherwise there's no point in even proceeding with a repair on the ports, especially considering how many jumpers we got to run. So that's why I always check those pads, because sometimes the M92T36 will fail in a way that will not show anywhere except those pads, so those test pads. None of the surrounding capacitors on the chip will be presenting, but those pads will. And here's hoping that is still the problem. Alright, so I see a few bridges there. I want to clear those before we go testing. Same deal as if you remove the port, you don't want anything bridged over. Alright, so let's go check that pad again. Make sure we have no short left. Remember, the short was right there, and it appears to be gone. Let's just double check. And that short is gone, and that was the only way we knew that M92T36 was short, was because that pad was short. It's tacked on at the moment. We want to get some more flux on there, I think. Roll one more time. Make sure it's flat to the board. Right orientation. Right, zero back in our test pads and make sure we do not have a short reoccurring once connections are all back in place. Find the ground. Okay, everything looks good, very good. Everything looks good to a degree. Now we got to clean up this disaster zone. Hey, we'll get to use our grinding pin today. I was already going to get to use it on a PS4, but the Nintendo Switch is taking precedent. You can guess why on the PS4. It's a pretty easy guess. Stubborn anchor joints, always so much fun. More low melt. Alright, let's get a look at this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 jumpers required. The 2 on the ends are ground, so we're not that worried about those. Oh no, 11 jumpers. Yay. Let's grab our grinding pin and get started. I'm not sure which tips are going to be best for this work. Well, I seem to be doing fine. Just have to come at an angle. This is so much faster than the X-Acto. I'm barely putting any pressure down on this. I'm just trying to get the UV mask off. It is very, very delicate for a grinder. It's nice. I mean, it does very delicate work. Not that it's very delicate. Excellent. Okay, my first experience with the grinder is, I'm quite impressed. Real quick, let's tin those so I ain't got to do it later. 6337 leaded solder. I'm kind of already tinned the joints too, so might as well do it while we're here. Cool. Alright, so first impressions of the grinding pin, it's pretty awesome, so we'll go with that. This many jumpers, I'm going to use actual jumper wire. If it were just a pad or two, I might use the lugs. The lugs come in such a low quantity and are so expensive that I don't want to use them on a repair like this. Apologies for not showing the other ones. I apparently had it off screen. But we will continue with starting with these next ones. I think that one's a ground one, but it's fine. Alright, pretty happy with that. Now, they still have to survive cleaning. If they don't survive cleaning, they definitely won't survive placement. Let's get all these guys straightened back out. Dead center of the pad, preferably. And we will secure them down using UV solder mask. Okay. Alright, I'm reasonably happy with that. It should cure out nice and thin. I had to spread it out a bit because I put a little too much in areas, but that's fine. We'll scrape it off where we need to scrape it off of once it's cured, and then we'll tin up our jumpers. But first thing we gotta do is cure, and for that I'll be grabbing my big UV lamp and just sitting it on top of it. I'm gonna go eat some lunch while it's curing, and then we'll come back. Okay, I think we are well cured now, so I've eaten some lunch. Need to do some strategic scraping. Sure everything that we don't want to have conformal coating does not. Solder mask, rather. Yeah, we need to tin these jumpers. If they get soaked up by the soldering iron, they were not cured well enough. And I'd like to get that one pad tinned up pretty good as well. We'll be gentle, but we're not going to be too gentle. Yep, that one was not secured. Scrape the stuff on the end too, because I don't want to have a bunch of buildup. Dropping my air temperature about 240. I'm going to use it to assist in the curing of this one area. Just real quick. It will make it go quicker. I don't want to actually wet anything, so I'm being and it's already pre-tinned, so I'm not going to worry about that. Port prepping. Alright, one more routine for this channel. We'll bring the board temperature up enough to flow or enough to wet the solder on the pads. And then press down. And hold while it dries. Okay, we're getting some wetting now. And when I hit that hidden area a little bit, I'm going to press down and hold. Okay. Let's do our normal nudge test. Very lightly tapping, but it should give you no movement, and it feels pretty good. Feels pretty solid. As always with jumpers, it's nice to get the charging on both sides, but the true test is, will it dock? Okay, let's perform some initial testing through the power supply. We're looking at channel 1, which is on the left side down below on the overlay. Let's see what kind of behavior we get. Okay, that seems relatively normal. Switch around. Okay, looking good. So on both sides, we're getting it. Now what I want to do is channel 2, which will be on the right hand side on the overlay. And what I'm using as a battery dongle is a modified iPhone battery power squid that I have retrofitted Nintendo Switch connectors to, light and regular. And let's grab our OEM charger to activate and make sure it is doing something like booting. You want to see just a steady climb in amperage here. And it looks like it is. Very good. Alright. I'm pretty happy with that. So, we know it's charging on both sides and it appears to be booting. So let's put it back in the housing and do some initial testing. And then, like I said, the big one is, will it dock? Okay, we're ready to test with my battery that has a charge in it. So let's test. Make sure we get a normal boot up. So we don't have additional problems. Full battery symbol. Alright, and touch. Very good. So we're booted up. Let's check our other side. Make sure we're charging both directions. And we are. Excellent. So, we're charging both directions. That part is solved. We still don't know if we're docking, but I'm going to have to let it charge on its own battery for a while before we all know that. And then we'll kind of go from there and see how everything works. Alright, and as you can see, it is docking. I am super excited about that. We got it on the first attempt. Sometimes it takes many attempts to get it to dock when you're running 11 jumpers. So, yeah, I'm pretty excited. Okay, so we are docking. You saw that. Do want to check over everything we normally check. Make sure it's charging both Joy-Cons. It is. And as you can see, it's drawing 15 volt, fast charging at 1 amp. Check our internet. And we are. Very good. So that's really all I want to do on this one. My main concern was it was no power. It clearly had some port damage, so we didn't bother plugging it in. We removed the port. We found 11 pull pads under the port. The port had been really dorked. You could tell the shield was broken loose and everything. We cleared the bridges under the port. We tested the N92T36. Everything around the N92T36 tested out fine, but one of the test pads was shorted that connects to N92T36. It was the only way it was displaying bad, so we pulled the N92T36, tested the test pad again, no more short, put a new one on, no more short. So the N92T36 was also bad, but it was presenting in an obscure way. So new N92T36, we ran the 11 jumpers, we put the port back on, first try, we got it docking, so I was very excited by that. Sometimes it takes multiple tries to get those jumpers to connect sometimes. Anyway, that's all I have for you on this repair. If you liked the video, do me a favor, hit the like button, and if you want to see more like it, hit the subscribe button, maybe notification bell, and you'll know when I post videos, usually about twice a week. If you have any questions about the equipment I use, take a look in the description below. They're all linked down there. Most of them are linked down there. It's all Amazon affiliate links, so if you click on any of those links and buy anything during that session, it helps support the channel, and I am greatly appreciative for anything you do there. We also have some other support links down there if you want to take advantage of those. That's really all I had to ask of you. I really appreciate you watching. We'll see you next time.